All right, here is the 5.9 homework where we're dealing with approximate integration. So this is midpoint formula, trapezoid formula, Simpson's rule, that kind of stuff. And so they give you a function 1 over the natural log of x. And this is a function that I don't believe we know the antiderivative of. So we couldn't just calculate the area underneath the curve from 2 to 4 of this function. So what we could instead do is estimate it. And what they're telling you is to estimate it using the midpoint rule with 3 subdivisions. What that means is M3 if you go back to those formulas I gave you. So that shouldn't be too bad. When you get your answer there, it'll be some decimal approximation because you won't know 1 divided by the natural log of, I don't know, 2.5 or whatever the numbers end up being. But when you get that decimal approximation, you round it to 4 decimal places, and then it should accept that answer here. Question 2 is kind of the same idea, except they switch the function, and they make it the square root of x squared plus x, another function for which I don't believe we have the antiderivative. And instead of figuring out M3, you figure out S4. So hopefully these two will be manageable, maybe a little bit tedious, but doable. If you don't like those two, you're especially not going to like this one. Trapezoid rule, that one's a little bit easier. Yeah, maybe, except that now we have n equals 8. So that's going to be obnoxious having to use n equals 8 with this formula. Sorry about that. Note that cosine is in radians here and not degrees when you're plugging this into your calculator at the very end to get an answer that needs to be accurate to at least 2 decimal places, it looks like. So at least they're not super picky on the amount of decimal places you have to carry throughout these problems. So that should get you through 2 and 3, and then we get to 4, the last one that's required. It's one of the error-bound formulas. So they give you the function that we're talking about, and then we need to use trapezoid rule and Simpson's rule with n equals 4 and calculate the error bounds. So it's the same function, which is kind of nice. For the trapezoid rule, I believe it's the second derivative you want. For Simpson's rule, it's the fourth derivative. So you'll be taking some derivatives of this thing, which shouldn't be too bad. Just remember chain rule. N stays constant as 4. And so you can calculate what k is equal to in each of the 2 different cases, and then figure out what your error bounds are, and those will go here and here. And then finally, question 5, extra credit. Do it if you want. You don't have to if you don't want to. It's similar to question 4 in that it's only dealing with error bounds. But what they're giving you is the error bound, and they're asking you for what n is equal to. If you go back to these formulas, you'll still calculate k just like you've been doing, and then you'll have a number in place there. But instead of putting a number in for n, you'll set this equation equal to a number that they give you in the problem. So you'll set it equal to 0.1. So imagine this with an n here and equals 0.1. And then maybe you can solve this equation for n. Take the denominator here and multiply it up to the top on the other side, and then divide and take like the 4th root or whatever root it ends up being with the numbers that you have. And that'll allow you to solve for n. A couple of comments. If you do work on this problem, I mean, it's a fair amount of work to do, and I'd hate it if you did all the work and then we're just slightly off because you didn't read this little hint at the bottom. So n needs to be a whole number, so round it up. So if you decide that n is 16.1, I know normally you'd think 16.1 should round to 16, but you round it up. So if you got 16.1 as your answer, you'd make it 17. And be careful, if it was a Simpson's rule problem, Simpson's rule problems n has to be even. So if you got 16.1, you'd round it up to 18. So if you got 16.1 for the trapezoid rule, you'd type in 17 here. If you got 16.1 for Simpson's rule, you'd type in 18 here. And it's not 16.1, that's just a number that I made up to illustrate what I'm talking about. So start by taking derivatives, second derivative or fourth derivative, depending on which one you're doing, and then figure out what k would be equal to by figuring out how to make the absolute value as large as possible by plugging in these endpoints here. And then put all that into your formula and set it equal to these values and solve for n. And if you do all that, you can get the extra credit question, but it's beyond anything that you really need to be able to do for this class, which is why I made it the extra credit question. One thing that I just noticed that was a little bit different than what I did in the video, so I want to make sure it's clear, is when you are using the trapezoid rule and you're trying to figure out k, you have to take the second derivative of your function here. And you take the second derivative of this function and you want to make the absolute value of the second derivative of this function as large as possible by picking a value of x between -4 and +2. And what I told you is on all the tests and stuff, I'll always make sure that the value that maximizes the absolute value of that derivative, second derivative in this case, will be one of the endpoints. In this specific case, I think it ends up not being an endpoint. I think because this is negative and this is negative, it'll end up being when x equals 0. It'll just be at this constant value. So what I'm saying is when you're trying to determine k, for the trapezoid rule one, I don't think this will be an issue for Simpson's rule, but it will be for the trapezoid rule. The value of x that you'll put in to make the absolute value as large as possible will be x equals 0, which is in between these two values, -4 and 2. It's not one of the endpoints, even though I promised you on tests it would always be one of the endpoints. Hope that makes sense.